Question 14. A state study on labor reported that 1/3 of full-time teachers in the state also worked part-time job at another job. For those teachers, the average number of hours worked per week at the part-time job was 13. After an increase in state teacher salaries, a random sample of 400 teachers who worked part-time at another job was selected. The average number of hours worked per week at the part-time job for the teachers in the sample was 12.5, with a standard deviation of 6.5. Is there convincing statistical evidence at the alpha level of 0.05 that the average number of hours worked per week at part-time jobs decreased after the salary increase? So let's set up some hypotheses and then maybe just run the tests in our calculator. So this is going to be, in this case here, are some previous data where the average number of hours per week at the part-time job was 13. So that's going to be like your mu null. That's going to be your null hypothesis. After an increase in state teacher salaries, a random sample of 400 teachers, so there's your n value, who worked part-time at another job was selected. The average number of hours worked per week at the part-time job for the teachers was 12.5. So it's only one sample. This is going to be your sample, and this is going to be your sample mean. This 13 was kind of like your default, what we're trying to compare it to. And then it's got a standard deviation of 6.5. So S of X is 6.5. Is there convincing evidence that the average number of hours worked per week at part-time jobs decreased? So that's going to be less than. So now we can actually set this up and we're going to run the test right in our calculator. So this is going to be a one sample t-test. So in our calculator, we will go to stat, tests, t-test, option 2. Select stats. We're going to input our mu null as 13. That's what we're comparing things to. We're going to put our sample mean, 12.5, our sample standard deviation of 6.5. We'll put our sample size of 400, and we want to select less than. And we can go ahead and calculate. And we're going to get a p-value of 0.0623. You can also do the same thing here by going to draw if you want to visualize what that looks like. This kind of helps you with the interpretation of a p-value. Remember, the p-value is the likelihood of getting a sample as extreme or more. And you're going to see that 0.0624 there. So let's look at our p-value. And now we can make our comparison. So we know that we have a p-value of 6%, and that's going to be higher than 5%. So we're going to fail to reject. And we do not have convincing evidence in this case. So, no, we don't have convincing evidence. It's going to be a no. Cross out the yeses. The p-value is not less than 0.05. So the p-value is greater than 0.05. So we don't have convincing evidence. Not convincing evidence. We fail to reject.